Hi, and thank you for joining me once again. Glad you're here today. Today we're going to continue with our systems of equations. Today we're going to solve systems of inequalities by graphing. So remember, when we graph an inequality, the part of the graph representing the solution is shaded. So for a system of inequalities, the region where the shading overlaps is the solution region. And we'll take a look at that here in just a second. So our first example, solve each system of linear inequalities by graphing. So we have this system here, y is less than or equal to 3x minus 6, and y is greater than negative 4x plus 2. Okay, so just a couple of reminders here. Remember, when it's less than or equal to or greater than or equal to, our graph is going to have a solid line with shading, and when it's just less than or greater than, it's going to have a dashed line with shading. So this line will be solid, this line will be dashed. Okay, so they're both in slope-intercept form. So if we graph both of those, first one has a y-intercept of negative 6. So I put a point down here at negative 6. And we have a slope of 3, so we go up 1, 2, 3, and over 1, 1, 2, 3, over 1, put a couple more points, and again, solid line, so I connected the line. And now for our shading, we have to remember which side of the graph do we need to shade. So I use the test point 0, 0. Let's see if it works. Is 0 less than 0 minus 6? So 0 is less than or equal to negative 6. Well, that one is not true. So this is not in our solution area, so it must be the other side of the line. So I have shaded over here to the right of this line. Okay, next one has a y-intercept of 2. So I put a point at positive 2. It has a slope of negative 4. So we go down 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, plotted my points. And this time, remember, we need a dashed line. So I put a dashed line there. And so let's try 0, 0 again. 0 is greater than 0 plus 2. So 0 is greater than 2. Once again, that's not true, so it's going to be shaded on the other side of the line. So I have the shading over here. And remember, our solution, like we talked about, is the overlapping region of both of those. So here's our solution region, is where those two shading areas overlap. So right in here. So remember, we always want to try to check our answer if we can. So I'm going to just find a point in the solution region. How about the point 3, 0? That one's probably easy to work with. So the point 3, 0 is the solution, or is in the solution region. So if we put it back in here, 0 is less than or equal to 3 times 3 minus 6. So 0 is less than or equal to 9 minus 6. 0 is less than 3. That is true. And 0 is greater than negative 4 times 3 plus 2. So 0 is greater than negative 12 plus 2. So 0 is greater than negative 10. That again is true. So since both of those, since that point works in both of the equations, it seems like we probably have the correct area shaded here. So as long as we graphed carefully, we have the correct region shaded. Okay, moving on. Next example. Just another quick example, y is greater than or equal to negative 3, and x is less than 2. So here's just an easy reminder of graphing vertical and horizontal lines. So remember, y is greater than or equal to 3. Well, remember, this has a slope of 0 and a y-intercept of negative 3. So if we go down here to negative 3, slope of 0, and it's greater than that, so it's going to be shaded above. And if you're not sure, try 0. 0 in the y direction. 0 is bigger than negative 3, so that works. So we definitely shade above. And x is less than 2, so we have a dashed line. Remember, that's a vertical line at 2. And since it's less than, we're going to shade to the left of it. So our solution region is this region here where the two overlap once again. Okay, so now let's try one with maybe an absolute value in it. So we have y is greater than 1/2 x plus 2, and we have y is less than negative absolute value of x plus 2 plus 5. Okay, so I did over here, I made a table of values. for the absolute value, just to make it a little easier to graph that. So remember, our vertex is going to be where this is equal to 0. So x plus 2 equals 0, so x must be negative 2. So I centered my graph around negative 2, picked some other points to the left and right of negative 2 and plugged them in. So if we put in negative 4 plus 2 is negative 2, absolute value makes it positive, but this makes it negative again, so negative 2 plus 5 is 3. And negative 3 plus 2 is negative 1, but absolute value is positive. This makes it negative, so negative 1 plus 5 is 4. Negative 2 plus 2 is 0. Absolute value is still 0. So 0 plus 5 is 5, and then so on. So we have our table of values. So for that, I plotted the points on the graph and drew my lines for the absolute value. And it's going to be less than. So we need to decide, is it going to be shaded out here or underneath? Well, if we pick the point 0, 0, 0 is less than the opposite of the absolute value of 0 plus 2 plus 5. So this would be 2, but make it negative. So negative 2 plus 5 is 3. So 0 is less than 3. That is true. So that is part of our solution region. So we're going to shade inside or kind of beneath the graph here. Remember, it is a dashed line, of course. Okay, so now we'll graph the other one. This one's in slope-intercept form. It's a little easier. Y is greater than 1/2 x plus 2. So go to plus 2 on our y-intercept. 1/2 x. So we go up 1 and over 2, or we could go down 1 and over 2, down 1 over 2. So we have a set of points there. Connect our points with our dashed line. And it's greater than this time. So let's try 0, 0. 0 is greater than 0 plus 2. 0 is bigger than 2. Well, that's not true. So we don't shade this side of that line. We shade the other side of that line. So it's above. So notice this time our overlapping region is bounded on all three sides here. So it makes this triangular region right here is our solution region. So it doesn't have to go on continuously when we have a situation like this. Okay, last example here. Example 2, find all of the whole number solutions to the system of equations. So this time it's a little different example. They want us to find the whole numbers solutions. And remember, a whole number has to be a positive number bigger than 0, and it has to be one of our counting numbers. So 1, 2, 3, and so on. Okay, so we have a fairly easy system to graph. X plus y is less than or equal to 4, and x plus y is greater than 2. Now, you might notice that you could probably kind of do guess and check and figure out what all combinations work here, and that would work as well. You could make a table, but since we're working on graphing, it seems logical to go ahead and use graphing for this particular situation. So if we put in, let's graph by intercepts. So if we put in 0 for x, and so to find out where our line is going to be, think about this as being equals. 0 plus y equals 4, so y would have to be 4. So our y-intercept is at positive 4. And our x-intercept, if we put in 0 for y, 4 plus 0 equals 4. So our x-intercept must be at 4 also. So plot the two intercepts, connect them with a line, and we are good to go. And x plus y is greater than 2. Notice I haven't shaded yet. We'll talk about that in just a second. I'm just getting the lines at the moment. So again, our x and y intercepts are going to be 2, but this time it's going to be a dashed line. So I have both of our lines. Since this one is less than or equal to, we would shade below. This one, since it's greater than, we would shade above or out here. So our solution region is right here, because remember, we need whole number solutions. So we need them to be bigger than or equal to 0. So this point right here, because this is a solid line, this point would work. This point would work, but this one would not work because then it would be equal, and we don't want this one to be equal. Okay, so this point and this point, these 2 points would work, these 2 points would work, and I notice now I missed one other point. The point 40 would also work. So here is our list of points that would satisfy this stipulation of they have to all be whole numbers. Okay, so again, if it were if it were not whole numbers, we could shade in this whole region in between the two graphs, and it would continue on into the negatives for y here and negatives for x here. So that's all I have for you today. Thank you for joining me, and I hope to see you again soon.